I put up some code into the content section, this bst underscore partial.cpp. Okay, this is kind of a piece of code that you can use to kind of get started with your binary search tree. So if we just look through what's in here, we have this struct, which is going to represent the nodes of our tree, right? Because we need to have a left side and a right pointer for our tree hierarchy. We have basically our class definition. I'm going to remove the comments in here just to make it a little smaller, but the comments will be in the file on D2L, so you can see them. So you can see I have two function prototypes here in our constructor. I have two private function prototypes here in our constructor. Don't get too hung up on why there's two of these. Why do I have a partial insert function and a partial insert helper function here? Right, so the general idea is when we're going to end up having to do recursive things with linked data structures, it's kind of easier to have this two-step process to make everything a little bit easier to grasp. These two public functions are just there for the user to call. They are just what are known as wrapper functions. The user will call this function, and then this function will in turn call the function that's going to do the actual work. Right? Because the function that's doing the actual work may need more information than the user has access to. So for instance, because we're going to be doing recursive steps with our preorder and our partial insert helper function, they effectively need access to the private root variable in our class, which we do not want to give our user access to. So we just create these wrapper functions that will in turn call these functions which have access to those variables directly. So it's just a two-step process. If we wanted to see what this looks like, here is our wrapper function, and all our wrapper function does is basically call our actual partial insert helper, which does the actual recursion for us. So we can look and see what this function is actually doing. So here, to kick start our insertion, we can basically call partial insert helper. We pass it the value that the user wants to insert into the tree, and we pass it the root of the tree that we want to work with. So in that function, right, this is going to be our recursive function that's going to do all this nice work for us. I hate it when word wrap takes over. Right, the first thing we see is our base case. So our base case is when the root or the node that's passed into us is null. We know that we need to make a new node, set its value, and then we return that node back up our chain. Remember, all of these recursive functions are kind of going to happen in this big long chain that's going to keep growing with the size of our tree. So if we want to just kind of step through this once here, let's just go here. I'm going to erase this stuff. So right now, let's say root is null. Okay, so root is null, and the user calls partial insert, and let's say val equals 7. Okay, so they pass 7 into this function, so we're going to say root equals partial insert helper, and we're going to pass it value, and we're going to pass it root. Okay, so that means when we call partial insert helper, value is going to equal 7, and node, the name of our parameter, is going to equal null. Okay, at that point, because node is equal to null, we just create that new node, and then we're going to return it to whatever function called us, which in this case was just the partial insert by itself. Okay, we're not going to actually reach our recursive step this first go around. So after that function runs, instead of root pointing to null, root's going to point at, our node 7, right? And that's going to point to null, and that's going to point to null. Our left and our rights are both null. Okay, so now let's say the user came back and they called our function again, and this time they passed it 7. Okay, so this time we'd come back in here, value would be 7, and we would call partial insert helper again. Okay, this time root, I guess we already put 7 in there, better number, 6. So this time root is no longer null, correct? And value is going to equal 8. So root is pointing at the current node that represents the root of our tree. So we know we just completely skip over this part, and we fall down into our else statement. In our else statement, we have node left is going to equal partial insert helper value, and we're going to pass it the value of node left. Okay, so this is our recursive step. So we're saying the left pointer is going to equal whatever our recursive function returns. Okay, so in this case, when we call partial insert helper, we are passing it two things. We're passing it value, and we're also passing it the value of our left pointer. All right, so when we come back around and we hit our recursive function, value will be 8, and node is going to be null, because that's what we just sent to that function. So we would fall in here, we would create a new node, set its value, and we would return whatever it was, which at this point would set our left pointer equal to that new node. So now instead of null being there, we would end up having 8 with both of its pointers pointing to null. Okay, and I know this is not the correct binary search tree ordering, but I just wanted to get you guys a feel for how this insertion stuff works. And once you see how the insertion works, you can start figuring out, okay, how do I apply the binary search tree rules to make this all happen? Okay, so that ends that function. This return node at the end is just kind of there for housekeeping purposes. Later on, I would suggest that you remove it and see what happens to your tree and see once it works. But for now, don't worry about that. Just know that you know it. Okay, so we just inserted the new element into our tree. So now let's say the user wanted to insert 10 into the tree. So it would come back. We would jump into our function. We would pass it value, which is going to be 10. Just pretend like that's a good 10, and we're going to pass it the root of our tree. So we fall in, and we say, okay, is node equal to null? No, it's not, because node is currently pointing right there. So we know we need to fall into our recursive step. And now our recursive step says, okay, node left is going to equal our recursive function, and we're going to send it value, and we're going to send it node arrow left. So when we call that function, instead of node pointing up here in the recursion, node is then going to point down to where our left side is. All right, so we come back up to the top, a new recursive call is made, and we look, okay, and we ask, is node equal to null? Which in our case here, node is not equal to null. So again, we fall down and we hit our recursive function for the second time. So again, we would call our recursive function, we're again passing it val, and we're again going to pass into it the left pointer of node, right? Which in this case, the left pointer is going to actually be null. So when we hit the top of our next recursive function again, remember we are now 3 functions deep. right? Node is going to point to null. So now node is going to equal null. We make our new node and we return it. When we return it, node arrow left is going to equal it. So that effectively hooks up our new node here. And we keep setting null and null. So this stuff, this pattern is going to continue over and over and over again. So every time we add a new node, we're going to go one layer deeper in our recursive step, right? This whole idea of inception, it happening over and over and over and over again. Right? So this is basically how the insertion is happening. Once you kind of wrap your head around how this is happening, then you can go ahead and actually write the rules to say, okay, if this number is greater than my value, I need to go to the right. If this number is less than my value, I need to go to the left. It's just a matter of saying, okay, which pointer do I want? Do I want the left pointer or do I want the right pointer? Okay, so again, this code is going to be on D2L. There's going to be a lot of comments in the code. Make sure you look at those. I also have a couple prototypes, or I guess I have a prototype for a pre-order traversal in here. Okay, see if you can figure out how to translate the pre-order traversal from our array example to this linked list example. Once you get that and understand that, how that traversal is happening, then this code is also going to be much easier as well. So check out that code, play with it, make sure you download it and run it. If you have questions, get a hold of me. I'll try to help you walk through it as best as I can. Because this whole first go around with all the recursion stuff is going to be hard until we kind of get back in the game of it and the feel for it. So get a hold of me if you have any questions, and we will see you in the next video.